Welcome to Ask and Learn.
Hello student, in this problem an industrial load is given which have a series parallel combination of RLC component, right? So first there are an inductor which have a value of inductance L and a resistor R and a capacitor C. Okay, the value of resistance R is 200 ohm and the capacitance is 50 nanofarad and the inductor is L and assume that is the ZTS. Now we have to find out the value of inductance L when the net impedance is resistive and it is at the frequency of f equals to 5 megahertz. Okay, so first we have to calculate the effective impedance of the circuit. So ZTH equals to, there are series combination of RC, then it is given R plus 1 upon j omega C and it is connected in parallel with inductor L. So it is j omega L. It is clear? So ZTH equals to A into B upon A plus B. I apply the series parallel rule. Then it is given j omega L R plus 1 upon j omega C upon, so upon A plus B. It is simple, R plus j omega L plus 1 upon j omega C. So now by calculating this function, it give j omega R L plus, by cancel out j omega to j omega, the result value is L upon C upon R plus j. By taking j common, then it is omega L minus 1 upon omega C. Okay, so now calculate the resultant of this function. ZTH equals to j omega RL plus L upon C upon, by multiply the complex conjugate, then the value of denominator term is R square plus omega L minus 1 upon omega C का whole square and multiply here R minus iota omega L minus 1 upon omega C. Okay, so in this problem the net impedance is resistive. Okay, so let's assume ZTH equals to, A plus iota B. ZTH equals to A plus iota B, where A is the resistive component and B is the inductive or reactive component. So when the circuit is purely resistive, then the effective reactive component will be 0. It means the imaginary component will be 0. If we have to find out our circuit will be purely resistive, then we put the imaginary component or reactive component will be 0, right? So ZTH equals to, from this problem, ZTH equals to 0 at when the circuit is resistive. Okay, so put the imaginary component equals to 0, then it give this value will be 0. By putting this concept, this value will be 0, and in numerator side j omega L R by multiply by R give the value of imaginary component. Then we put this value here, j omega R square L, and if we multiply j omega RL to this function, then it is give real value. So we have to ignore this value. And if we multiply L upon C by R, it also give the real value. Again, we have to ignore this function. And if we multiply L upon C by this term, then it give the complex quantity. So we have to write minus L upon C minus iota L upon C omega L minus 1 upon omega C equals to 0. It is clear? So by calculating this value, omega R square L equals to L upon C omega L minus 1 upon omega C. So by separate this function, it give omega R square L multiply by C upon L equals to omega L minus 1 upon omega C. Now omega R square C equals to omega L minus 1 upon omega C. And by solving this function, the resultant value is omega square R square C square equals to omega square LC minus 1. Okay, it is calculated by taking the LCM of this function and cross multiplying. Okay, so now the effective value of inductance L equals to omega square R square C square plus 1 upon omega square C. Okay, now this is the effective value of inductance L. Now we have to calculate the magnitude of L at the frequency of 5 megahertz. Okay, at the frequency of 5 megahertz, and the effective value of resistor is 200 ohm and capacitor is 50 nanofarad. Then by putting this value in this formula, the value of inductor L will be L equals to omega square R square C square plus 1 upon omega square C. So first we have to simplify this equation. Then it is omega square to omega square cancel out, C square to C also cancel out. Then this give R square C plus 1 upon omega square C. Okay, so now L will be, what about the R? It is 200. Then 200 square into capacitor is 50 nanofarad. It is 50 into 10 ki power minus 9 farad plus 1 upon omega square. Omega is simple, 2 pi f, and 2 pi, and frequency will be in the system is 5 megahertz. Then it is 5 into 10 ki power 6 whole square into capacitor is 50 into 10 ki power minus 9. Okay, so now by solving this equation, the value is 2 into 10 ki power minus 3 plus 0.2026 into 10 ki power minus 3, and then value of inductor L is 2.203 millihenry. This is the resultant value of inductor when our circuit impedance will be resistive. So in this problem, what we have to, first we have calculate the total impedance of the circuit ZTH and apply the concept. The resultant ZTH is 0 if the resultant impedance of the circuit is resistive. Then we ignoring the real component and put the imaginary component will be equals to 0 and find the value of inductor L. And by putting the value of all these parameters like capacitor, resistor, and the frequency, we can calculate the effective value of inductance L. Thank you so much.